So here we have our ratios. We're going to try to find some equivalent ratios. So I want you to make sure that you can find the equivalent ratio parts, but also I want you to show me the multiplying and dividing factor involved here. So for here we have 25 to 75 comparison. Okay, so we want to know what the term is here that compares to 15. So if we take a look at this here, we can find our multiplier by just dividing. Okay, so if I divide 75 by 15, I get times 5. Now, since times 5 is going in this direction, or sorry, the opposite direction here, we can show this as a divide by 5. We can say that this is divide by 5 going in the direction, the opposite direction. So this direction, we see it times 5. So the opposite direction should be a divide 5. So 25 divided by 5 gives me 5 to 15. And again, some of you may have noticed that this is a 1 to 3 ratio, so you could have worked it out using the horizontal multiplier. Here, our multiplier going from top to bottom, okay, is I'm going to divide 18 by 3 to get my multiplier. And this becomes times 6 going from top to bottom. So I'm going to end up with 8 to 3 is the same as 48 to 18. Here, I want to go from top to bottom. So I'm just going to divide 21 divided by 14. Okay, that gives me 1.5. So my multiplier then is 1.5. And I can use that multiplier to go 8 times 1.5. That gives me the proportion of 12. So 14 to 8 is same as 21 to 12. 14 to 8, 8 is slightly bigger than half of 14. 12 is a little bit bigger than half of 21. So that looks about right. Okay, and again, we want to make sure that we understand this proportion vertically, but also that understand that this proportional relationship exists horizontally as well. So in this case here, we could do 12 divided by 18, and we can have our multiplier as 0.66 repeating. I can round that to 0.67. Sometimes these numbers are a bit messy to work with. So if I can see that I can avoid those repeating decimals or those non-terminating decimals, I would use that multiplier instead. So in this case, I'm going to go 18 divided by 12. Okay, so in this direction, I have a times by 1.5. So I'm going to go in the opposite direction and divide by 1.5. Okay. Now that is the same as if I did 12 divided by 18 and said I'm going to instead multiply by 0.66 repeating. Okay, and that would achieve the same thing. But this is a much cleaner number. If we can use a cleaner number, it is to our advantage to be able to do that. So multiplying by 1.5, I'm going to get 9. Okay, so this is, divided by 1.5, I'm going to get 4. Okay, so we can actually see that this horizontally, this is a divide by 3 ratio, so we could actually use the horizontal divisor, which may have been nicer to use as well. Going from middle to bottom, okay, 9 divided by 6 is 1.5. It's going in the right direction, so I'm going to times. So I'm going to end up with 27. Okay, so same thing here. I want to divide 144 divided by 18. That looks like it is, looks like 8. Okay, so we have times 8 multiplier. Okay, 16 times 8. Okay, that works out to be 126. Okay, so 144 to 126 is the same as 18 to 16. Going from middle to bottom, 20 divided by 16, that's going to give us 1.25, so I'm going to times by 1.25. Okay, so 18 times 1.25, that's going to give us a decimal value. It's going to give us 22.5. Just double check that. Times, yeah, it's going to give us 22.5. Okay, so it's important to understand that now with fractions we tended to use whole number ratios. Okay, technically a fraction should be whole number ratios, but we're not going to limit ourselves to whole number ratios anymore, and our multipliers don't have to be these nice perfect numbers anymore. We may end up with some messy numbers. When we can avoid those messy numbers, we do though.